Imagine this, it's a hot day, the sun is shining, and you're sweating for being outside all day. So you go inside and grab an ice cold beverage from the fridge. How refreshing. But wait, what if you didn't own a fridge or even have electricity? How would you keep your produce from spoiling or control the temperature of your medicine? In some parts of the world, people have no access to electricity or expensive appliances, such as refrigerators.
A Zeer pot can solve this problem. It's able to keep items cool without the need of electricity, while also being extremely cheap to make. And we're going to demonstrate just how to make one. So these are the materials you're going to need for a Zeer pot. You're going to need one larger, porous, unglazed pot, and one smaller, porous, unglazed pot to fit inside.
Next, you're going to need an amount of sand to fit in between the outer pot and the inner pot, and a towel. Okay, so the first step you're going to need to do is to prepare your pots. If you have pots like ours, which have a hole in the bottom, you can simply take any type of tape, such as we have right here, and apply the tape to the inside of the pot, creating a watertight seal, such as that. Next, you're going to do the exact same thing on the second pot.
All right, so next you're going to want to fill in the larger pot with enough sand so that the smaller pot is level with the top of the larger one, like so.
Okay, so the next step you're going to want to do after you have the inner pot level with the outer pot is we want to fill in this area around the pot with sand. Don't worry if you get some sand in the inner pot, you can always take it out later. Okay, so the next step you're going to want to do is slowly pour water in a continuous motion in this area between the inner pot and the outer pot. Wait for the water to settle, and if the sand starts to settle a little bit as you're pouring the water in, you can simply add some more sand. You're going to want to do this until the sand is saturated with water. Okay, so once we have our sand and our water added, we can see that we have sand up in between the inner and the outer pot, and the sand is saturated with water. If we take a look at the outside of the pot, we can see that it's starting to get a little bit wet. This is because the porous nature of the terracotta pot is allowing the water from in between the inner and the outer pot to be drawn out to the surface of this pot. So as we have wind moving along the side of the pot, we're going to have convection air currents flowing alongside it. That's going to allow this water to evaporate. When the water evaporates, it's going to draw heat energy from outside of the inside of the pot out into the air, thus cooling down whatever we put inside this inner pot. Okay, so your next step is going to be to bring your Zeer pot outside into a breezy environment. Place your produce or whatever you want to keep cold in the inner pot, and then simply take a damp towel and place it over the top of everything to insulate your produce. This works best if you're in an arid environment with a strong breeze, but it'll also work if you're in a humid environment. It just won't cool as much. Okay, so unfortunately it started raining outside, so we had to bring the pot inside. Our pot was outside for about an hour, and it's about 87 degrees outside. So now we're going to take this infrared thermometer and check the temperature on the inside of the pot, see how our results are. Oh, wow. Right now you can see that on the thermometer it displays a temperature of about 73 degrees. So we can see that that's more than a 10-degree difference between the inside of the pot our tomatoes in the outside ambient air temperature. Wow, that was a lot of work, but now our Zeer pod is outside, and as the water begins to evaporate, energy will be drawn out of our tomatoes and keep them fresh. Keep in mind that the Zeer pot works best in arid climates with a steady breeze. Depending on your local environment, the inner temperature of your Zeer pot may drop as low as 40 degrees Fahrenheit. While this may not be quite as good as a refrigerator, it's definitely better than leaving the produce in the sun. By leveraging the simple scientific concepts of heat transfer and evaporation, we were able to preserve these perishable goods so that they last longer.
We've demonstrated one way that science can be applied to the real-life problems and help people in developing countries while having some fun along the way. Now we challenge you to take our vision and turn it into a reality.